Hey guys, let's work on some problems using the fundamental theorem of calculus. This one is very important, right? So let's do some problems. So before doing that, let's revise the fundamental theorem of calculus. F is continuous function on a closed interval. And if you define this function like that, if you define this function from AB close interval to real line, right? So then F is continuous, you can show that, right? And differentiable on this open interval. And if you differentiate this bit, this integral, you get same lower f here, this f here, right? Okay. Alright, let's find the derivative of this integral here. Look at this integral. So this one is very difficult to integrate, right? Think so. By using the fundamental theorem of calculus, so this can be evaluated. The derivative of this integral can be evaluated very easily, right? So let's write, yeah, this bit. So this bit here, f of t is defined, lowercase f of t is defined as t to the t, right? T to the t. This function is continuous uh, on this interval, yeah, on this interval. So this function is continuous, and capital and uppercase F would be this part here. So if you define function uppercase f of x is somewhat like from 4 to x t to the power t dt. Here t is the dummy variable, right? So here, so this is dummy variable, nothing to do that, right? So this is a function. The whole integral is a function of x, right? So when you differentiate uppercase f with respect to x, so what you get according to that fundamental theorem of calculus, you get lowercase f of x. That's it, right? So you know f of t is equal to t to the power t. So f of x is x to the x. This is the derivative of this integral. Derivative of this integral is same with this one here. Easy, right? Alright, let's work on this problem here. So find the derivative of this integral. What is the integral? T to the power 10 plus t to the t cube, everything to the 1/3. So if you are given this one to integrate, it is very difficult to integrate, but the derivative of this integral is same with so if you define this one here, let's define this bit. This bit is equal to f of t, right? Lowercase of f of t. So let's take this bit is equal to f of t. So according to the fundamental of calculus, so you must get this one here. Sorry. You should get lowercase f of x, which is equal to t to the 10 plus t cubed to the 1/3. Not t, x. This should be x. X, right? This should be x. X. F of, right? Alright. The next question, find the derivative of this integral. Here x is greater than or equal to 5, right? So look at terminals here. X, the integral goes from x to 5 here, but you know that you can interchange these terminals. You can sub these terminals to get that integral to this form, right? This form. When you sub those terminals, you have to add a minus sign. 5 from 5 to x, t to the t, dt. Right. So the derivative of this integral, we know that this one, the derivative of this integral is, so here you have minus, and this one here, x to the power x. So if you are given these type of questions, so here x is greater than or equal to 5, right? And the constant term on the upper terminal, right? So when you have this problem, you can interchange these terminals, then add a minus sign, right? Then you can use that fundamental theorem, fundamental theorem of calculus. So according to that, this bit is equal to x to the power x. Then you get the answer. The next question, find the derivative of this integral here. Here look at, notice terminals. Here starting from a constant to x cube. Not x here, x cube. Definitely you have to use chain rule, right, to compute this derivative. Alright. So let's denote this bit here. F of t, lowercase f of t, right? And let's denote per case of x cube is this one here. Trigger from 2 to x cube, the sine of t over 1 plus t to the power 5 dt. Right? Alright. So now we have to evaluate the derivative of this integral. Let's write that down. d by dx f uppercase f of x cubed. Now let's use the chain rule. D by dx cubed with respect here we differentiate uppercase f with respect to x cubed, and dx cubed by dx. So according to the fundamental theorem of calculus, this one is same with f lowercase f of x cubed, right? And this bit here is equal to 3x squared. We know function f is this one, just subbing x cubed, just replace x cubed here, then you get f of x cubed. Wait a second. What is our function? Our function is that. Then our solution is 3x squared, this term here, times f of x cubed. F of t is this, and I subbing x cubed into t to that one, sine of x cubed divided by square root of, don't have any space here, square root of 1 plus x cubed to the power 5. So this is the answer. This is the derivative of this integral is equal to this one. So using the fundamental theorem of calculus and chain rule, I think you understood this, how to apply, how to use the fundamental theorem of calculus, right? How to evaluate these derivatives of integrals, and I think you can do exam questions very easy. Alright, let's do another question. Wait a second. So how do you compute the derivative of this integral? So here notice these terminals. Here x, the integral goes from x to x cubed, right? Not from a constant value to x. Here goes from x to x cubed. Alright, so let's denote cos of t is equal to f of t lowercase f of t, right? So definitely if you look at terminals here, so definitely can say that, so if this one is greater than or equal to x cubed, right? So if both terminals are equal, right, what happened to this integral? it is equal to 0, then the derivative of this one is 0. Turns out to be 0. Alright, x, so here you have x and this is x cubed, or other way around, if x is greater than 1, right? So you can say that this is true, right? And if x is less than 1 and positive, so what happened? X cube is less than x, right? Can consider both cases. You don't need to write these things. What I want to say is you can choose. So you can choose a point in between x and x cube. Some point say a constant a, right? So now I split this integral into two integrals. So let's do that. Integral goes from x to x cube. I split this integral into two integrals, x to a to x cube. Right? Now I take the derivative. Here, look at this. Now I take the derivative with respect to x. So d by dx, d by dx, d by dx. This operator. Now you can apply the fundamental theorem of calculus separately. Consider this one first and then this one. Then if you combine both answers, then you get the final answer. Then you get the derivative of this integral, right? So first apply the fundamental theorem. Alright, let's do that. Let's find this one, d by dx, from x to a, and that garbage, what is that garbage? Not cos of t, simple function, cos of t dt, right? So you can interchange these terminals. When you interchange these terminals, you have to add minus sign. Right? And d by dx from a to x cos of t dt. This one is this one is same with cos of minus cos this same function, cos, we write x instead of t there. Alright, so we just considered only this part. Now we consider this one here. Alright, definitely you have to use chain rule because here you have x cube. Right, let's consider that part. D by dx from a to x cube cos x cube cos of t dt. Then what is the answer? So here you get cos of x cube times the derivative of x cube, which is 3x squared. Alright, the final answer would be this one plus this one plus minus, yeah, this one minus, and this one minus cos of x. Alright, this is the answer. So what was the problem? Let's go to problem. There are this one here. So take the derivative of this integral, which is equal to this one, cos of x cubed times 3 times x squared minus cos of x. Alright, so good luck, guys.